What's coming off around here?
Did you guys play railroad anymore today? Did the lads like the new cut?
Welcome back to the Fun with HO Scale Stuff channel. What you see here is the complete disassembly of an HO scale SW7 Athearn built locomotive model. Now it was the frame, the shell. What you see here are from the parts from the trucks, front and rear truck, and parts from the motor. A little aside, this video is actually about the repair and cleaning and reassembly of the locomotive. This is a little bit of an aside. This little figure you keep seeing is my representation of Dan Thorne, who is the intro character for this channel. He's a tough-looking thug, but got a heart of gold. But my point is I plan on modifying this figure to simulate a Dan Thorne. And, of course, he's going to become the superintendent for the Lehigh Valley Terminal Railroad. We'll get the job done with this guy. But enough said about Dan. Put him back here. He keeps an eye on things. All right. Come on, Dan. Pay attention. There you go. The first thing I want to do in reassembling is it'll start from where it ended, and that is this flywheel was spinning on its motor shaft. It wasn't really functioning. And after some careful examination, I discovered, I don't know how much of you, let me move up here and hopefully it'll focus. I discovered that this piece, I'm holding in my right hand, is supposed to go through the flywheel, thus, and it's supposed to, if you look at the back of the flywheel, it's supposed to be tight within that metal shim that they have pressed into the flywheel. And it's not. So that's why the flywheel is spinning. It doesn't really grab the insert properly that ultimately attaches to the shaft. So what I'm going to do is I'm going to come up with a means for making this insert tight within the flywheel so that once I put it back on the motor, on this shaft, it's going to be turning just like the other, like it should be, tight enough where that the motor rotates when you turn the flywheel, not just the flywheel. So let me proceed with that. So this is the flywheel, and this has been spinning on the motor shaft and not really doing anything to help the motor to be smooth. So I want to get that repaired, and the way I think I'm going to approach that is this piece right here is the insert, and the portion of the insert that we're looking at to expand is this portion of it's a sleeve-like portion that's on the end of this paintbrush. And that portion right there has got to be a little bit thicker, not a whole lot, just a little bit thicker so that it's snug inside when it's pushed into the flywheel and then onto the motor shaft. So my idea is to put a tiny amount of epoxy onto that plastic. Now the plastic you're looking at, that's that real shiny plastic. It's an ultra high molecular weight polystyrene, generally sold as UHMW, and it's very slippery. It's so compact in its structure that the surface has a greasy feel to it. So getting the epoxy to bond is probably my best bet, but in order to make sure it adheres in any way, I'm going to have to do some scratching and, well, cleaning and scratching to create a rough surface so that the epoxy can bond to something. So that's what the intent is. We'll see if that works out. So the first thing I'd like to try to do is roughen the edges on this. So I'm hitting it with my file. Sorry for moving it around. Let's see. Well, the surface is being roughed up, as you can see, but I'm not concerned yet because that surface is still very slick, a very hard, non-porous surface of this plastic. And I don't think it's going to take the epoxy very well. So I'm afraid that there'll be some shearing forces applied that'll just simply pop off the epoxy when this gets pressed into the flywheel. So I'm going to drill a small hole in the top of this so that the epoxy can be applied, and then it will also have some greater grip inside of this thing that it'll help it to sustain some of those lateral forces that'll be applied. The shear forces are what I'm most concerned about, not so much compression. So let me go ahead and drill that. Okay, so after I had to actually manhandle this thing to get it to drill, but after doing that, I've been successful in creating a small indention into the plastic. So this should be able to hold it. So I just want to clean whatever oil might be on here, and I'm going to mix up some epoxy and put it on there, and I'll show the epoxy after it's hardened. So I have several different glues. I actually have an entire box of different types of glues, and this is the epoxy that I wanted to use. And you can see from this container that very little hardener has been used, and so you know this is still full and unused. And I've tried to open it, and nothing comes out. And so we'll put that back on there. I came up with another solution to try to open this thing, and there's some success. And you can't see in there, but that epoxy resin has hardened on me all by itself. So this is the only reason I'm showing this, is because this is a good reason for anybody out there who may happen upon this video. Don't buy large containers of epoxy because it just winds up in the trash. Fortunately for me, I have a backup hope. This has also been in my possession for a while. So I'm going to try these little ones out and see if they work. So I'm in luck, and the small containers are still functional. And hopefully you can see, well, let me zoom in a little bit. The idea is to mix the hardener and the resin together. And the operative word is mix. Like they should be equal parts, by the way, as I tried to make that as equal as possible. But I've discovered that the longer you mix it, the more likely it'll work. And there are instances where I've mixed epoxy in the past and it never hardened. I mean, it went by days and it was still soft. So this mixing process I've discovered is quite important. So I'll just continue mixing here for a moment, and I'll come back when I finally have it. Okay, so I've got it mixed, and it's actually begun to be a little bit tacky. So I'm going to apply some of it to the insert. And I'll try and get it down into, let's see if I can get that off of there first. And I want to try to get it down into that hole for sure, because that's where I'm going to be battling my shear forces. So there goes that. And smear this over. I might have, well, it depends on how well it hardens, but clearly it would be too high now to be able to be inserted, so I'll wind up having to, take off some that. There it is. All right. I'm going to let that harden. I'll know it's hardened when I can't lift this toothpick off of that paper. All right, now the epoxy is dried, and as you can see on the insert that there's a slight raised portion, a slight bump on it. So the next step then is to insert it into the flywheel. And test that we have, oh good, friction fit, yeah, that'll keep it, oh yeah, that'll keep it from spinning. So it should come through flush to this side, which it does. All right, so that was a success with the epoxy. Well, the next order of business is going to be to clean the commutator on this motor. It's fairly dirty, so the brushes aren't going to be making as good a contact as they could. So in order to clean the commutator, I need to remove this flywheel from the end of the motor shaft. Okay. Now the purpose of doing that is so that this piece of the motor can be removed. So I've taken some fine grit sandpaper and I've scrubbed around the commutator a few times to remove as much of the nasty business off of it as I can. And it's come out fairly clean. It's much better than it was, so we'll call that a cleaning. I'll put this washer back onto the motor shaft. There we go. And we'll put the end piece back on the motor, and then we'll put the flywheel back on the motor shaft where it was. Press it down on there. That fits nice and snug. Okay, we'll check that. All right. So far, so good. Now I'll have to put the brushes back in and the clips on the top. So the first thing to go into are the brushes. Now the brushes have a certain amount of wear, that there's a certain amount of curvature that conforms to the commutator. So I'm going to put the curved part face down to help that. There we go. And a spring. It took flight. Okay, I retrieved the spring. I'll put it back in there. Okay, so I need to put the clip on. Now, this is the top, and it had been discovered earlier that the clip with the little tabs on it goes on the bottom. So the one I want up here is the one without. So I'm going to have to, well, put this clip on there, but it's kind of a, I don't know if it'll show up on the camera, but the clip is very clean on the inside, but on the top of the clip, there's some contamination on there. It looks like it might have been just finger oil that might have gotten on it, but the bottom side where the spring was in contact with it looks to be pretty clean. I don't think there'll be a problem, but I'll give it a quick shot with the sandpaper just to make sure that we don't have conductivity issue with that. So there it goes. There, nice and clean. So the clip is designed to go over the, there's a bulk portion on this part of the motor. I don't want to call it front and rear because it's a little bit awkward to say that right now, but this part of the clip with just the bend goes over this protrusion, and then the clip itself depresses the spring. It depresses the spring and then it snaps down. So that, simple as that. Kind of dislike that crap on there, so I'm going to give that a quick buff. It came off pretty easy. It looks nice. There's that. So we do the same thing on the other side. Put, again, the... I'm going to use the rounded, there's a slightly rounded edge on one side of this contact, so I'm going to make sure I put that down so it comes in contact with the commutator and it'll rest easy. And we'll put the spring, oh gosh, it's just not, it's not easy to pick it up. So put the spring back in. All right, so the spring is in. This actually, I think it needs a little bit of cleaning, and I think I'm going to bend those tabs down a little more to make them a little more aggressive on the contact there. And I'm going to give them a little buff. Clean them up. There's that. And there's that. And we'll take a look at where the spring is at, and it looks a little nasty, so I'm going to clean that part of this copper piece up. It cleans up pretty easily. That'll give us some good. There we go. And again, it's pretty much the same thing again. We just going after a little more aggression on this thing. We have this large extension that the hook goes onto, and then the clip goes onto the rear and snaps down just like that. Now the motor is assembled. So I can test the motor to see whether or not the windings are working. So I got my trusty DC power supply back out, and I've got some voltage that I'm applying right now. 20 should do plenty. And I'll take the, I've got the power clip attached to the bottom, and I'll just touch the top. If the windings are good, the motor will turn. Aha! Good windings. All right. Well, that's what we needed to know before I go any farther. So the next thing I want to discuss is what I need to repair here, this motor mount. The motor mounts are both broken, and I have a plan to replace these with something I fabricated. We'll see how that plan works out as I go forward. May or may not actually work, but I have to give it a try. My plan is to use this piece of plastic to reconstruct the wall portions, the flat portions of the motor mount. And as the tubular portion of the motor mount is what gets inserted into these holes here. And of course, the way Athearn had installed this motor mount was that apparently it was pressed through from the top, and then the bottom was melted. And if you look carefully into that frame, hopefully you can see that there is actually a ridge, so that the melted portion formed a clamp that would hold the motor in place. I can't do that. So what I've decided to do, well, maybe I could, but actually I have a better idea, I believe. When I make this shaft here, I plan on using material from the Evergreen scale models. It's these tubes, and this is the package that I had. It was a 7-piece assortment set. Now, these 2 pieces actually telescope the smaller end to the larger. So my objective is going to be to fabricate the cylindrical portion using this material and these tiny screws that you see laying here. And the screws will come in from the bottom of the frame into the plastic portion and allow me to attach the motor and actually make it possible to remove the motor again should I have that need. Plan on it, but it's my idea. I got to do it. So let me go ahead and start fabricating these new motor mounts, and we'll see how that turns out. Well, the video so far has actually become rather long, so this will conclude episode 3, part 2 of the efforts to save this Athearn SW7 locomotive. So please tune in to the final part 3 of this series to view the conclusion of saving this antique model. Thank you for viewing, and would you please, if you could, like and subscribe.